Welcome back to another episode of Mr. A's Geometry Podcast. Today I want to take a quick look at addition with you. So the addition postulate comes up in a lot of different proofs. We can see it in parallelograms and triangles and all sorts of different places. But it's really pretty much the same every time you do it. This is the simplest example of an addition that you can possibly have. And a lot of times when you have addition in a proof, it's going to look very much like this, but there'll be other things around it. So we want to get good at this basic step first. Then when we add other things to it, it's not going to throw us off so much. So first of all, how do we know that this is an addition problem? Well, let's take a look at what we're given. AB congruent to CD. Well, let's mark that. AB over here, congruent to CD over there. So we know that those two little pieces on the ends are congruent, and they want us to say that AC is congruent to BD. So these larger pieces, AC and BD. Well, how do you go from small pieces to larger pieces? You have to add. That's how you know it's addition. Now, the question is, what are we going to add? Well, how do you get from AB to AC? You have to add BC. And how do you get from CD to BD? You have to add the same BC. So that's what we're going to be doing. We're going to be adding BC to both of these segments and proving that AC is congruent to BD. So let's get started. We have our given AB congruent to CD. I want to do some addition, but I need something to add. Remember, addition lets you add two lines in your proof. So I know that AB is congruent to CD. What do I want to add? Well, we just said we want to add BC to AB and BC to CD. So we're going to add BC to both sides here. That's okay to do as long as you're adding the same thing. So in step 2, you're going to tell me BC is congruent to BC. What kind of step is that, by the way? Let's reflect. So now that you've told me BC is congruent to BC, we're ready to go ahead and add. Right? You're going to take the first line of your proof and add it to your second line. We're literally going to add what's on the left. We get AB plus BC. Congruent to, we add up what's on the right. BC plus CD. That's an addition step. And remember, addition is one of those postulates where you have to tell me which steps you're adding. So in this proof, I'm adding steps 1 and 2. So we'll write addition on steps 1 and 2. Now you might think we're done because we did the addition, right? But the thing is, we haven't shown that AC is congruent to BD yet. See, it might be obvious to you that AB plus BC is AC, but in geometry, obvious isn't good enough. We're doing a proof, remember. So what step is going to let you tell me that AB plus BC is congruent to AC? That's a partition step. So in addition, the next thing we need to do is partition. You're going to come here in step 4 and tell me, look, AB plus BC, well, that's just exactly the same thing as AC, right? And you're also going to tell me BC plus CD is exactly the same thing as BD. All you're doing here is a partition step. The whole is equal to the sum of the parts. So it's partition. And it does not require you to tell me which steps. You can always do a partition. Now here's the key. This is what makes the addition work. The first thing you did here was you gave a reflexive so you have something to add. We went ahead and added the first 2 lines of the proof. Partition lets me say that the left-hand side here is really AC, and the right-hand side here is really BD. So now what we're going to do is a substitution. We're going to take this line, and we're going to rewrite it in step 5. But this time, and here's the key, instead of AB plus BC, I'm going to substitute AC. And instead of BC plus CD, I'm going to substitute BD. My reason is substitution. And again, remember, substitution is one of those that you need to tell me what steps you're substituting with. So, we're substituting this step with our partition. So steps 3 and 4. Put a proof box to show you're done. And that's all there is to addition. So with addition, remember, once you do the addition in the beginning, you're not done with the problem yet. You still have some work to do to tell me that what's on the left and right really is what you want to say. In this case, AC congruent to BD. That intermediate step is a partition, and then substitution finishes it off. I hope this helped you out. If you have any questions, please let me know. If you'd like to see me do a particular proof on this video, please let me know. I'll be happy to try to fit it in. Thanks for watching, and have a great night.